today's video, we will talk about prime factorization, where we will be finding factors using only prime numbers. There are ways to determine the prime factors of a number. This can be done by doing the factor tree or a method called repeated division. A short exercise is also included towards the end of this video. If you need help with prime numbers, you can always check the link below. Have you ever come across the term prime factorization? Prime factorization is simply finding which prime numbers multiply together to make the original number. In other words, the factors must only be prime numbers. Prime numbers, as we all know, are those numbers with only two factors, 1 and itself, just like the numbers 5 and 7, where the factors are just 1 and itself. Let's have a quick look at the list of the prime numbers between 1 to 100. What are the numbers that are prime? We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. See the difference between factors and prime factors or prime factorization. Let's find the factors of 12. In the previous video, we learned that factors are numbers multiplied together to get the original number. Number 12 has many possible combinations, like 1 times 12, which is the same as 12 times 1, 2 times 6, or 6 times 2, and 3 times 4, or 4 times 3. The factors of a number can also be obtained by finding the divisor that would divide a certain number with no remainder. So 12 can be divided by 1, 2, 3, 4, 6, and 12. All these divisors are the factors of 12, but not all are prime numbers. To do prime factorization, we only need the prime numbers. Which of these factors are prime numbers? Let's see. 1 isn't the prime number. 4, 6, and 12 are not prime numbers as well. So the only prime numbers are 2 and 3. As we know for sure, to do prime factorization is to express the given number, which is 12, as the product of the prime factors, which are 2 times 2 times 3. There are various ways how to do prime factorization. The very common is the factor tree. In this method, we simply break down the original number into much smaller numbers until all the factors are just prime numbers. For example, 36. This number can be broken down into the product of 9 and 4. 4 and 9, however, are not prime, and so this still can be broken down further. 4 can be expressed as 2 times 2, and 9 can be split into 3 times 3. Now the factors are all broken down into prime numbers. If you chose to do a different factor of 36, you may do so. You can begin with 6 times 6, then later split both 6 into 2 times 3. Regardless, in whichever way you want to show the prime factors of a number, you will still get the same answer. This means 36 can be expressed as the product of prime factors 2 times 2 times 3 times 3. Another way to do prime factorization is by doing repeated division. In this method, we continuously divide the given number using only divisors that are prime numbers. How do you express 42 as a product of prime factors? Let's try dividing 42 using only prime numbers as divisors. I always tell my students when we do lessons like this one to not overthink. It means it is always best to start dividing using the lowest possible prime number so you won't struggle. Since 42 is an even number that is divisible by 2, and 2 is also a prime number, we might as well start with 2 as the divisor. Taking half of 42, we will get 21. Continue to divide this number further. What prime number can we use to divide 21 with no remainder? Again, it is easier to try the smaller number first, which is 3 obviously, and this leaves us with 7. And since 7 is already a prime number, there's no need to continue dividing further. 42 can be expressed as the product of the prime factors 2 times 3 times 7. Before we finally end our lesson, let's try answering this simple question. What is the highest and the lowest prime factor of 390? You can always pause this video if you need more time to think. But if you're ready, let's go ahead and check your answers. First, we must find all the prime factors of 390. Let's try doing this using the factor tree. Since this is a 3-digit number that ends in 0, the obvious factor is 10 and 39, which are not prime. 10 can still be broken down into prime factors of 2 and 5. 39 can still be split into prime factors 3 and 11. Now we have all the prime factors. 390 can be expressed as 2 times 3 times 5 times 11. Our highest prime factor is 11, and the lowest prime factor is 2. Well, I do hope this lesson is helpful for you in some ways.